Yeah, so my name's Alexander Hanumis. I'm the UPS product manager at Eaton Industries for the power quality business in Australia and New Zealand. Eaton is it's a multinational company. It's based in the US, trades on the US stock exchange. It has 4 divisions. So it has the electrical division, which I'm part of, which is the largest division. It then has an aerospace, hydraulics, and a vehicle division. Eaton as a business invests in products that are used for power management, so within special applications. So power is in electrical, hydraulic management. Within our UPS systems, the batteries that we use is anywhere from a 9 amp hour block, which is quite a small battery which fits within the UPS, to a 200 amp hour battery block, which is quite large. From there we then parallel multiple strings of batteries depending on the autonomy time for the UPS systems that are required. So they can be in a package anywhere, you know, the size that can fit on my lap, or in a large room for a big UPS system within a data center or hospital. Depending on normally the small batteries are used in applications within offices, in workspaces, in mining, in control rooms and things like that. They're also used in aerospace applications to provide backup power for radar systems, as well as security in airport. The large batteries are used in data center applications where a large amount of critical power is required, so anywhere from 1 megawatt to 2 megawatt system. Batteries represent a unique challenge in that a battery cannot be turned off. So once a battery has a charge, there's always a potential across the terminals, whether that potential is 12 volts, or in a large battery string you might have 480 volts, 500 volts, and so on. So within our risk controls, we cannot eliminate the risk that a battery presents simply by turning it off, because a battery cannot be isolated, it's always live. So that presents a unique challenge within our equipment. So due to that, we've had a number of instances recently where unqualified personnel or contractors who are unfamiliar with batteries within the UPS system have worked on the equipment, and they've shorted out the batteries and injured themselves. Within Eaton itself, we train our service technicians, particularly on how to work on batteries and how to risk mitigate themselves injuring themselves or causing an incident on the batteries. Externally, we provide documentation with our UPS systems on how to, for electricians, on how to work on the batteries, as well as signage on the systems alerting them to the arc flash risk. But unfortunately, sometimes those control mechanisms do not work, and we find that people are still, in some instances, injuring themselves while working on. So recently, in the past year, we've had 2 incidences on our UPS systems. The first one was in Western Australia on a control room for a mine site, where a qualified electrician, they were quite new to the industry, so when we looked at their experience, they'd only had 2 or 3 years experience within the electrical industry. They were replacing batteries on the UPS system, and while they were replacing those batteries, they did the wrong connection and they shorted out some terminals within those batteries. That then caused an arc, and they injured their hands, so they burnt their hands and had to go to the hospital for treatment. Generally, the batteries are located in spaces in actual control rooms. So the control room itself isn't a confined space, however it is a room that's generally you won't get general access into that room. So first of all, the contractor or the person working on that system will need to get permission from the company that operates that site. So they should do a job safety analysis, as well as issue swims at the beginning of the work in order to get permission to do that. From there, they need to identify the risks within the safety analysis. And generally the risk for working on batteries is the arc flash, so you need to wear protective gear. And in the instance we had, the person wasn't wearing the appropriate protective equipment, so that resulted in the burns on their hand. And they also need to have the correct work procedures in order to not eliminate, but reduce the risk of shorting out the batteries. Recently we've changed our design to have a easy swap, or what we call an easy swap battery cubicle. So within the risk mitigation and the risk controls, what you want to do is try and eliminate the risk first of all. So what we've done is we've placed the batteries into battery packs that can easily be swapped in and out of the UPS systems by electricians and maintenance personnel. That eliminates that personal arc flash risk of the equipment itself. But generally, with the PPE level, we look at the energy potential within the arc flash itself.
Incident energy.
Yeah, incidence and energy, and that's placed into categories. So we have category 1, 2, etc. From there, the PPE equipment has a CAL rating, and we use that CAL rating to then assess what PPE the person should be wearing. So depending on the energy that's contained within that hazard, it can be anywhere from normal gloves to wearing triple layers of gloves to having a full helmet and shield on as well. The other important point that we get from the CAL rating is we then can assess the distance from the equipment the person needs to be when they need to wear that equipment, wear that protection. So an example is if a battery bank is smaller, they may only need to be 1 metre from the equipment, and within that 1 metre space they need to wear PPE. After that they don't need to wear PPE. If the batteries are extremely large and they have a higher density of energy, that may move out to 2 metres or 3 metres where they need to wear the personal protective equipment. So the workers, in terms of PPE, initially when the industry started to become safer and safety became the #1 priority of companies, there was a lot of resistance against wearing PPE for the reasons why you said, because it was in hot environments it became quite difficult to wear it. The personal protective equipment 10 years ago, 15 years ago was quite chunky and quite clunky as well. So there was a lot of resistance against wearing it. The company's policy is safety first. So Eaton have a zero tolerance rule on safety. It's their #1 priority with all decision-making processes that are made within Eaton. The very first question that needs to be asked is this safe? And if it isn't safe, how do we mitigate those risks? So from there, the workers in their work practices have been forced to find practices where they need to wear PPE where required, and that's not it's not something that's negotiable. Or what they've also done is they've found better ways of working. So PPE is the last mechanism on the risk control matrix that should be used. The first thing you should do is try and eliminate the risk, or put in measures that move the personnel from the risk itself. So interesting things have occurred where if technicians are working on batteries or they're working on systems, what they'll do is they'll put panels over the batteries now, so they don't need to be wearing the personal protective equipment. They'll also set up meters in a certain way and their test equipment in a certain way so that there's distance between themselves and the batteries to minimise that time that they're in the risk zone as well. So those work practices have helped a lot with those problems. And the other piece is engineering out the risk. So with the Easy Swap battery packs that we've developed, the person doesn't need to be wearing PPE while they're moving the battery packs in and out because the risk is mitigated. There's definitely a challenge within developing countries on safety. Safety is an evolution. It's always changing and always adapting. Western world generally have more safer practices than what developing world countries do. First of all, Eden follows they have a global safety policy, which is Eden's policy, and they also need to follow the safety policies within the countries and the regions that they operate in. Whichever policy has the highest standard is what we need to follow. So Eaton's global safety policy standards, which was developed in the US, needs to be followed in all third world countries by Eaton personnel and Eaton contractors as well. And that's heavily audited, and then also the managers are trained in the processes, and then also the workers themselves are audited and trained in those processes within the developed countries. So while we might have a plant that's operating in India, for example, that plant must follow the US policy and the global policy and standards within Eden. My message is always put safety first, and safety changes. So practices from 10 years ago that were considered to be safe, now through experience are no longer, and we've had to change those practices. So in all your decision making, the way you develop the products, always put safety first and think about it as being number one, and be ready to adapt and change, because what you think is safe today and what your practices are today, 5 years from now, 10 years from now, will change based on experience and based on the requirements within the industry. On safety, we have there's training on a 12-monthly basis, depending on the skills and tasks that people have, and alert notices are also put out within the company to advise people of incidents that have occurred, and then updates to the policy. But the policy is constantly changing and constantly being adapted. I think it will benefit them because it will get them thinking about safety early on. Safety is also an extremely important factor within the electrical industry as a whole. If the product isn't safe, it will not go anywhere, or if your design is unsafe, it will not be taken up. So it's important that you understand the safety practices and the considerations, and that's basically the benefit that the topic will give you.